variation problems. There are 4 different types of variation, and the first one is direct variation. So direct variation, what it means is that as x increases, y increases directly. As x decreases, y decreases directly, or at exactly the same rate. So if you have 2 markers, and you want to say that these 2 markers double, then it's going to be 4. And if 4 doubles, then it's going to be 8. And no matter what, it's going to go directly. There's nothing being added or subtracted or making it wonky. The graph is going to be a linear function that always goes through the origin. The linear function could be steeper, it could be less steep, it could be negative, it can be positive, it doesn't matter. But it will always be a linear function that goes through the origin. It'll always be y equals something times x. We will not add or subtract anything to it. And that's something, we call that our variation constant. And the variation constant we always denote as k. The next type of variation is joint variation. And joint variation it's direct variation, except now there's going to be 2 constants over here. And so as x and y are changing, if they're increasing, y is going to increase. If they're decreasing, then y is going to decrease. And again, you have that variation constant, k. The third one is inverse variation. And what this one says is that as x is getting bigger, y is getting smaller, because if you divide by x, so if you divide by 2, then you're going to have 1/2. That's a smaller number. If you divide by 4, then you're going to have 1/4. And so as x gets bigger, y is getting smaller at exactly that same rate. This function will always look like this. It might be shifted left, right, up, or down. But one thing that you'll notice is that this does not touch the origin. You can't divide by 0. And so because you can't divide by 0, it's never going to equal 0, and you can't ever plug in 0. And so inverse variation, x will never be 0, and y will never be 0. And then the last one is combined variation, and it's called combined variation because you'll see that you do have a variable that's in the numerator and also in the denominator. And so this one, again, you can never divide by 0, and so you have to keep that in mind. But combined variation is combining direct and inverse variation. So let's do some examples of these problems. In this example, I'm so sorry guys, I just get nervous when I'm in front of the camera, but you know what, as long as you can laugh at me, that's fine. But you know the rule. You can laugh at me, you can pause, you can fast forward, you can rewind, you can do whatever you need to do to understand, but you can't make a meme of my face. Okay, so given y varies directly as x. It's a weird wording, but that's the way it's worded. And when y equals 14, when x equals 3.5, write and graph the direct variation function. So what we know is that y is going to increase as x increases. And so we need to find what is the variation constant. And so step 1, find the variation constant. The more you practice this, the easier this will get. You're going to find a trick very quickly. You're not going to have to go through all these steps that I go through. So y varies directly as x. And when y equals 14, when x is 3.5. And so I have 14 here. That's what y equals. And that's going to equal some number times 3.5. Well, if you think about this, how do you figure out what number times 3.5 gives you 14? Oh, you just divide the numbers. And so now, if you're thinking about solving this algebraically, you just divide both sides by 3.5. And that's going to give us what k is. And I really feel like I should be able to do that in my head, but I love my calculator so much that I'm going to use it anyway, just because why not use my calculator? And I should have been able to do that in my head. It was 4. So k is 4. And what that means is that whatever my x value is, if I multiply it by 4, that's going to give me my y value every single time. So if my x value is 3, what's my y value? Let me think. Oh, 3 times 4, it's 12. If my x value is 1, what's my y value? Thinking, wheels are turning. Oh, 1 times 4 is 4, so y has to be 4. So our equation here, let's use a different color. We love Superman colors, or Spider-Man, except red doesn't work. That's unfortunate. That's okay. So the next step would be to write the equation. I don't think we're going to be able to use the red, guys. I'm so sorry. We're going to switch this up to Christmas. Oh, blue and green are Christmas. We're switching this up to Seahawks colors. All right. So next step is to write the equation. And we know that y equals 4 times x. Or output is always 4 times our input. So there's our equation. You can always double check yourself to make sure it works. You can plug in 3.5 and is 4 times 3.5 really 14? If it is, you know you did it right. So that's great. Okay, and step 3, because I haven't finished answering the question, is graph. So to graph this, draw your little, let's count 1, 2, 3, 4. Okay, direct variation is always going to start at the origin. By looking at the equation, you know that anyway, because our y-intercept would be whatever you're adding, and you're not adding anything, so we're going to start here. And then here's our slope. And so we're going to rise 4, and we're going to run 1. So rise 4, run 1, you can keep doing that. You can get a really nice, beautiful graph. Connect your points. Hopefully it's straightish. And there we go. There's our graph, and that's going to tell us the answer for anything on this curve. Like we said, when x is 0, y is 0. When x is 1, y is 4. When x is 2, y is 8, and so forth. And so that's why it's important to graphics. It shows all the solutions in the set. Many times you're going to see these direct variation problems as word problems because that's how they appear in real life. So this direct variation problem, hopefully when we get to the answer, it's going to look familiar to you because you learned about circumference in 7th grade, 5th grade, 4th grade. I don't know. I only teach high school, so I'm not sure when you learned about circumference, but you did at some point in your life before you met me. So the circumference of a circle, C, varies directly as the radius r, and C equals 7 pi feet when r equals 3.5 feet. Find r when C equals 4.5 pi feet. What the heck is 7 pi feet? Man, that sounds like we're talking in a foreign language. We kind of are. We're talking in the language of math. 7 pi feet would be 7 times pi. Pi is 3.14, blah, 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 blah. And so this is like approximately 21 feet, but by using pi, it's an exact answer. So the circumference is 7 pi feet when r is 3.5 feet. And we know that it varies directly. And so our equation is going to be something like C equals K times R. And so our first step would be to solve for K. We want to figure out what K is so that we can build an equation that works every single time. We know a set of numbers, and so we can figure out what K is by using those numbers. So let's plug in 7 pi for C, so 7 pi, and remember that's just 7 times pi, equals K, we don't know what K is yet, times 3.5. We want to get K by itself so that we can build an equation, and so we're going to divide by 3.5. Leave the pi. Just do 7 divided by 3.5. Well, I had a thought in my head, it didn't work. 7 divided by 3.5 is 2. If you don't believe me, you can plug that into your calculator. And so what we have here is 2 pi equals k. The pi stays there because I didn't divide the pi out at the beginning. I just divided 7 and 3.5, so the pi stays there. So k is 2 pi, which means now I'm ready to write an equation that works every single time. So our equation is going to be c, circumference, equals 2 pi r. And that should look familiar to you. Circumference is always 2 pi times your radius. So knowing that, we can find what the radius is if the circumference is 4.5 pi. So we'll set that up with 4.5 pi equals 2 pi r. We're trying to get r by itself. So how do we do that? Let me think. Oh yeah, we divide by 2 pi. So when you divide by 2 pi, the pi's will cancel out. So we want to know what is 4.5 divided by 2. What do you think? Well, I think it's going to be 2.25. So r equals 2.25 feet. Don't forget your units. And if you're not sure, you can always double check yourself. Is 2 pi times 2.25, does that equal 4.5? And it does, 4.5 pi. So there we have it. There's a word problem in the form of direct variation. Did you catch it? I was making a weird face before my camera lady hit play, start, whatever. Anyways, okay. I'm gonna stop you. Do this now. The area A of a triangle varies jointly as the base B and the height h. And A equals 12 meters squared when B equals 6 meters and h equals 4 meters. Find B when A equals 36 meters squared and h equals 8 meters. So, varies jointly is what we see here. And jointly is just another type of direct variation. So when we see jointly, all of your variables still go in the numerator. There's no denominator here. One of the ways that makes this easier for me is as soon as I see the word varies, I put an equal sign. And when I put that equal sign, then I know A is on this side of the equal sign, and the other variables are on the other side of the equal sign. And so step 1 is to find K. And I know that I have A equals because I see that word varies. K always follows your equal sign. It's always the very next thing, even though it doesn't say something on there. So A equals K times B times H. Right there, I pointed in the wrong place, sorry. So all of that is in your numerator, and we know it's in our numerator because it's jointly. The only time anything's going to be in our denominator is when we're talking about inverse variation or combined variation. So the area A of a triangle varies jointly as the base B and the height h. Find K, and we already have some information that allows us to solve for K. And so we know what A is. A is 12. We don't know K. We're solving for that. But we know that B is 6, and we know that H is 4. That gives us enough information to solve for K. So 6 times 4 is 24. Just giving you time to think. So 12 divided, or equals, K times 24. Now to get K by itself, we'll divide. Oopsies. And 12 divided by 24 is 1/2. So K equals 1/2. You can write it 1/2, you can write it 0.5, whatever you're more comfortable with. So now that we've found K, we can write our equation. So step 2 is just write the equation. So our equation is A equals 1/2 base times height. That equation equation seems really familiar. Let's reread the question. Why does this seem so familiar? The area A of a triangle. What's the formula to find the area of a triangle? 1/2 base times height. So that's a really good way to check your answer if you know what we're talking about. So we wrote the equation. I'm pretty confident that equation is correct because I know how to find the area of a triangle. And now step 3 would be to find the base. So step 3 is to solve. So we're going to plug in what we know. 36 equals 1/2 times base times 8. Well, 1/2 of 8 is 4. So this is the same thing as 36 equals 4 times base. How do I get b by itself? Divide by 4. 36 divided by 4 is 9. So our base is 9 meters. So we want to make sure that we keep the same units. And there we have it. In this question, it's saying y varies inversely as x. And y equals 3 when x equals 8. Write and graph the variation function. So this one's different because it says inversely. But just like before, every time I see this key word, I put an equal sign here. The variables on this side will be on the left side of the equal sign. The variables on the right side will be on the right side of the equal sign. And k always goes right next to the equal sign. So inversely now means the variable over here is going to be in our denominator. Because as x increases, y decreases. And so when I write my equation, it's going to be in the form of y equals k over x. Because that would give me something that as x increases, y decreases. So now I'm in a position where I can solve for k. And so we're going to solve for this guy. And we know one set of values that works in this equation. When y is 3, x is 8. And so that means that I'm going to have 3 equals k over 8. How do you get k by itself? We have 8 in the denominator. How do you get k by itself? Well, you have to clear your fraction. So multiply 8 here. That cancels out. And what you do to one side, you must do to the other side. So multiply 8 here. 8 times 3 is 24. And so we know k equals 24. Double check it. Does that make sense? Is 24 divided by 8 3? Yes. So now we have an equation that's going to work for every single one of these that are inversely related. So let's write our equation. Y equals 24 over x. Remember, when you're writing equations, you have to have a y and an x. You have to have those two variables in order for this to work. So now we can graph this. And you've got quite a few different ways to graph. You could make a table of values. You could analyze through it. What I do when I graph this is I just plug in 1, then I plug in 2, and then I plug in 3, and I start graphing those points. I can't plug in 0, because 24 divided by 0, the world explodes. And so what that tells me is that I have an asymptote at 0. It can never equal 0. I can't plug in 0. But I can plug in 1. 24 divided by 1 is 24. So when x is 1, y is 24. Okay. Then I can plug in 2. 24 divided by 2 is 12. And that's exactly halfway. Then I can plug in 3. 24 divided by 3 is 8. And I plug in 4. 24 divided by 4 is 6. And these are not very even anymore. You should do a better job making them even. But that's enough points to really see this shape. And the shape is always the same. And that reflects exactly this way. And so that same exact thing, so if it's 24 here and -1, you're going to have a point there. And so it's going to reflect exactly, and there's that other piece of it. In this example, we are going to look at the time t it takes for a group of volunteers to construct a house varies inversely. Again, I'm going to box that word and I'm going to put my equals k here as the number of volunteers v. If 20 volunteers can build a house in 62.5 working hours, how many volunteers would be needed to build a house in 50 hours? Well, the first thing I need to do is find k. You're probably finding that that's consistent across every one of these, is we've got to find that variation constant. So t is on the left side of the equals. So I'm going to have t equals k, because we always put k right after the equal sign, as the number of volunteers. As soon as you see this word inversely, where do you put the next variable? Do you put it in the numerator or do you put it in the denominator? We put it in the denominator. Hopefully that's what you said. If you didn't, that's okay. I'll forgive you this time. We're just learning. So t equals k divided by v. Now we're ready to solve for k. If 20 volunteers, so that would go here, can build a house in 62.5 working hours, how many volunteers would be needed to build a house in 50 hours? So we have this and this to solve for k. So we know that it takes 62.5 hours to build the house if we have 20 volunteers. How do I get k by itself? Well, I have to clear my fraction. I'm trying to get k by itself. So I'm going to multiply by 20 on both sides. And 20 times 62.5, I should be able to do that in my head, and I probably could. I'm just lazy. Is 12,050. So k equals 1,250. Not 12,050. That's a much bigger number. Equals 1,250. One thing that you'll notice is that k doesn't have units. It's a variation constant. Yeah. Okay, so k is 1,250, and now we can write an equation. So our time is going to equal 1,250 divided by v. Now that we have an equation, we have enough information to solve this. We want to know how many volunteers it will take to build a house in 50 hours. So I'm going to plug 50 in for t. And then we're going to solve for v. We have v in our denominator right now. We need to get v out of the denominator. And so our very first step is going to be to multiply by v. So right now what we have is v times 50 equals 1,250. Now we divide by 50. So v equals 1,250 divided by 50. I should be able to do that in my head. I probably can. It's 25. So v equals 25 volunteers. One additional step that I just want you to think about is, does that make sense? So it took 20 volunteers to get the job done in 62.5. Now we have 25 volunteers. Does it make sense to be 50 hours? Yeah, we have more volunteers. It should take less time. In this question, we are going to put together inverse and direct variation. And so we call this combined variation. And you'll get combined variation just by reading the question. So the volume V of a gas varies inversely. And so I see this word vary, so I'm going to put my equals K here. Now in this question, you're going to see the word varies twice. Put your equal sign with the very first varies that comes. So the volume V of a gas varies inversely as the pressure P and directly as the temperature T. A certain gas has a volume of 10 liters, a temperature of 300 kelvins, and a pressure of 1.5 atmospheres. If the gas is compressed to a volume of 7.5 liters and is heated to 350 Kelvin, what will the new pressure be? There's a lot of words in here. Don't let the words freak you out. I know you hate word problems. It's okay. We'll get through it together. So, the very first thing that we're going to do every single time is solve for that K. We have to find the variation constant. But we have two different types of variation happening. We have inverse variation and direct variation. And so it's important to know that when it's inverse variation, the variable that follows goes in the denominator. When it's direct variation, the variable that follows goes in the numerator. And whatever variable is before that first varies is what goes on the left-hand side. So we have V, or volume, equals, K always goes next to that equal sign, P. P follows the word inversely. And so we're going to put P in the denominator. Directly, temperature. So directly tells us to put it in the numerator. Now this is a real life science equation. This really is a science equation. You could check it. You'll see it a lot of times in chemistry because you are talking about temperature changes and pressure changes and you're trying to find volumes and all sorts of things. So this is a chemistry equation, and when I look at this I go, yes, that rings a bell. I've seen that before. I've set this up correctly. So volume equals K times T over P. Now we have enough information in the next sentence to figure out what K actually equals. A certain gas has a volume of 10 liters, so I would plug that in here. So I have 10 equals, we don't know what K is, and I always like to put a box around K just so I know that's what I'm solving for. A temperature of 300 kelvins, but we put the temperature up in the numerator, and a pressure of 1.5 atmospheres. And we're ready to solve for K. So you've got a couple different ways to do this. You could do 300 divided by 1.5 right off the bat, just so that you have a single number there. You can clear your fraction and multiply by 1.5 on either side. Yeah, I'm going to multiply by 1.5 on either side first. So I'm going to clear my fraction, and 10 times 1.5 is 15. That makes sense because 10 times 2 would be 20, and we want to get halfway there. And so 10 times 1.5 is 15 equals K times 300. How do we get K by itself? We divide by 300. So K equals, and 15 divided by 300, and it would make sense that it's going to be a small number. I did times in my calculator like a doofus. And K is 0.05. So our variation constant here is 0.05, which means I can write an equation. My equation is going to be V equals 0.05 times T all over P. Nothing else changed from over here. This is our equation that we wrote just reading the words, and then we solve for K, and so K becomes a part of our equation, and that's our general equation, so we can solve for anything now. So we want to figure out what our new pressure is going to be. Our volume is 7.5. Our temperature is 350. So we're going to have 7.5 equals 0.05 times 350 all over P. So we have P in our denominator. To clear it, multiply by P on both sides. If I multiply by P, this clears. I have P times 7.5. So in order to get P by itself, I'm going to divide by 7.5. So I'm going to have P equals 0.05 times 350 all over, 7.5. I'm running out of room here. And I'll put that in my calculator. Make sure you put this in parentheses. If you don't, then wacky things will happen. So I'm going to put 0.05 times 350 divided by 7.5. Oh no, I put an extra parenthesis in there. It's okay, we all make mistakes. And we get that the pressure is 2.3 repeating atmospheres. Don't forget your units.